Okay, let's talk about one of the most common, also the basic substituent that you're going to be working with in your alkanes and some of your alkenes. So, what is it? What are you going to be working with? What substituent? Substituent, remember, is just a group of atoms that you're going to add to your parent chain. It's not part of the parent chain, but it's going to be attached to the parent chain. Now, this is the alkyl groups, or the alkyl group rather. Okay, or if we say groups, I mean the different types of alkyls. Now, what are these? What are alkyls? Alkyls, these are saturated substituents. In other words, all the carbons in this guy will be having single bonds. Okay, all the carbons will be having single bonds, and they are only having carbon and hydrogen atoms. So nothing else. Carbon bonded to a carbon or to a hydrogen. Nothing else. And all the bonds are single bonds. Now, they are derived from alkanes. These alkyls are from alkanes, but what you simply do is you remove a hydrogen from an alkane, then you now have something called an alkyl. Okay, so that means you leave behind a number of carbon atoms behind, and these ones you can attach to some parent chain, right? We'll see some. Now, how do we then name them? When you are naming these alkyl groups, remember they are substituents, so there will be prefixes. So we'll put their location and then their name. When we are naming them, we always take the number of, we always check for the alkane that had the same number of carbons as that alkyl. Then when we give it a name, we'll just remove ANE and put YL. So, for example, if we have an alkyl that had 3 carbons, okay, it's coming from the alkane that had 3 carbons, like that, right? And if, let me finish putting the hydrogens like this. This is the alkane with 3 carbons. This one is called prop, then ane, because it's an alkane. So this would be propane. To name the alkyl, I would remove the hydrogen like this. Now I have the alkyl. What will be the name of this alkyl? I will remove ane because the family has changed, and I'll just put YL. So it will become propyl. So I'll have methyl, ethyl, propyl, butyl. Butyl is from butane. In other words, it will have 4 carbons, but we'll remove a hydrogen from one of the carbons and leave space for it to join on a chain. Now, when you do these alkyls, frankly, you're only going to do mostly just 4, the first 4. Methyl, propyl, ethyl, and butyl. Okay, but these guys are going to have some nice things about them. Let's see if we can go through it. We start with methyl. Let's go through this guy, methyl, right? So for methyl, what does it look like? Methyl was from methane, right? And methane had 4 carbons, like that. And all we are doing is we are removing 1, like this, like so. And then now we have space. So this is methyl. And methyl, we can also write it as a dash. Then we write CH3, okay, carbon. Now, this is your methyl, okay? And it has 1 carbon. And there is only one way for it to be attached, and that is through this 1 bond here, okay? So methyl has nothing complicated about it. And that's done. Let's look at number 2. Remember, we only have to talk about the first 4. What about ethyl? What is ethyl? Ethyl is from ethane. So you would have 2 carbons. Then you make it an alkane. The rest will be hydrogen spots, like that. Okay? Like that. And then this hydrogen that I'm putting as the last one, we'll remove it. And now we have ethyl. So this is ethyl. And when we write it, we say we put a dash. Then we say CH2. Then CH3. Okay? Now, this one has only 2 carbons, so it doesn't matter which one you call 1, it only has 2. So you could change this to be like, put the hydrogen there and leave the space here. It is still the same thing, okay? To say CH3, then CH2, okay? Same thing, all right? Now, so that is how you would write your ethyl, but we prefer this convention of leaving the end at the back. That's it. That's your ethyl. Now, what about propyl? Now, propyl things are beginning to get interesting at this stage. Propyl. What is propyl going to look like? First, I'm going to take you through the first one, the normal version of a propyl. Okay, what would it be like? Well, I could have 1, 2, 3 bonds like that, and then this, I put my hydrogens like this, leaving the end space. Okay, using the spot at the end. That is my propyl. Once you have something like this, then you have your propyl, and this is going to be called the normal propyl. So we'll call it the N propyl. Okay, because it's not the only one there. You say it's not the only one. What else is there? We have another version of propyl, and this is where things get interesting. It's called isopropyl. What is isopropyl? Look, I can attach. Remember that this is where you would attach to something. So I would put R. This is where you are going to attach to something long. Okay? And this something long will continue here and continue. And this guy would just be attached. Right? That's how it is. Now, what you then know is, okay, so this is how it goes. Now for propyl, we are, look at this first version, the normal propyl. The place of attachment is the end carbon, one of the end carbons. It doesn't matter which carbon it is. Okay, if I do this and I remove the hydrogen on this one, it's still the same. It's still N propyl. Okay, so I'd like to put it like that. It's still N propyl. Now the second propyl, so this is 3 carbons and we have them. And if we could put, we always start counting at the point of attachment, because this is where our side chain would just be inserted. Remember, side chain is not the main thing. So we start counting from where the side chain is inserted into the parent chain. So that'll be 1, then 2, then 3. That's an N propyl. Now we have another one. And you'd say, wow, what would it look like? The isopropyl. Okay, this is the N propyl, and if you were to put it, if you were to put the N propyl, you just say dash, and then you have what? CH2, because these are 2 hydrogens, then another CH2, then SCH3. Okay, that is your normal propyl, right? And if you are to put it as the bond line formula, you'd remember bond line formula. Remember that all the tips are carbons and the points are carbons. So the tips will be carbons unless you put an atom there or a molecule there or whatever it is you put, then it can cease to be. But as long as it's like this has 1, 2, 3 carbons. Okay, this is your N. This is your normal propyl, if we were to say that. Now what would happen? This is the normal propyl. Now what would happen if I would then come at the normal propyl? What happens is we add something here, and we normally break it like that to show that this is just a bond going somewhere. So this bond, we don't count it when we count the number of carbons. We count number of carbons at tips and at corners. So this is N propyl. This they can put an X to show that this white bond is just going to pair with somebody, or they can put those cross lines. Okay. Now the second one is going to be isopropyl. It's still a part of a propyl. This is the normal one. Then B will be isopropyl. What would it be like? Well, isopropyl, you would have your attachment being on the we can't say second carbon, but on a secondary carbon. Your attachment would be on a secondary carbon. Then we can say, all right, so the middle carbon, right? So if I do this, if I have my C, and I say C and then C like that, then I have my threes, then my 1 like that. Okay, so I would have H, 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 and then this one remains open. This is what your isobutyl is like, because this is where you're going to have your bond right here. Okay, if you were to put it in, so this would be isobutyl. If you were to put it in, if you were to put your isobutyl into the bond line formula, this is what it would look like. You put your isopropyl rather. You'd put your propyl, your propane, if it starts from propane, and we can call this our propyl. Now, where is our bond coming? It will come here at the center, at the secondary carbon at the center, and we can splash it to show that this is actually not a carbon. So it's just a bond from carbon. So if we were to count, okay, there are 3 carbons total, 1, 2, 3. But we never count like that. We always, when we count, we start at the point where it's connecting. So it'll be 1, 2, then the other one would be 3. Although we know we can't put them in one continuous chain. Okay, they are not 3 in one continuous chain, and that is where it fights with organic. Okay, so now, because we always start countering from where it is joining in. Okay, so your isobutyl kind of looks like a Y. You see, this is an upside down Y. We could have done this, and then we know that it's going to come to the secondary and just take a bond and leave this bottom empty. Okay, then you have to do that. Okay, so that you stop. Is that okay? So here we have our isoprotyl. Propyl, not protyl, but propyl, right? Now it is at the middle, or the secondary carbon. That is what makes it be called that isopropyl. It's at the middle carbon of 3, of only 3. All right, so this is propyl. We have 1, the N propyl, okay, the normal propyl, and then 2 we have this is the N propyl, and then 2 we have the isopropyl. This is how we write isopropyl. We write it in full as one word like that. Now, propyl, we've seen we have 2 cases. We said we are going to look at methyl, ethyl, propyl, and butyl. So now the last we want to look at is that butyl. Okay, so butyl. Propyl had 2 cases. Never forget. Okay, where did the other case come from? You had the point. It's coming from the point where you are going to attach. Now butyl has 4 versions. Butyl has 4 versions, and I'm going to put them. First one is going to be the N-butyl, which is the normal butyl that comes from butane, and we just remove a hydrogen at the end. That is going to be our N-butyl. So how is it going to be? 1, 2, 3, 4. Then we just remove a hydrogen at the end. We can leave it blank. We put the hydrogens like that. Okay, we put the hydrogens like that. This is going to be your N-butyl, or your normal butyl. If you want to represent it on the if you want to represent it using bond line formula, then this is what we'll do. Okay, even if you wanted to represent it using the compressed structural formula, it would be, the first one is 2 hydrogens, so it's CH2. The second one 2 again, so CH2. The third one 2 again, CH2. Then the fourth one CH3, and then do this. Now we are done with butyl. Butyl, if you want to then put it as bond line formula, you just do that. Do 1, 2, 3, and then 4. So if you count, you say 1, 2, 3, 4. The tips count and the corners count, right? All right. So now what would we do? What would we do? This is where it's going to come. The whatever that's going to bond will come on number 1. That means at the end, and that is your normal butyl. Now the second one, the second butyl, which we're going to learn. Let me label. Why is it not scrolling down? Okay. Good. So we've seen N-butyl. Now the second one which you're going to put is not even hard, and that is going to be the sec-butyl. Okay, the sec-butyl. This one comes from the same structure as normal, but it's just that the bond will happen on the second carbon. So what would we do in the sec-butyl? It's called sec. Sec for secondary. Why secondary? Because it is joining in to a carbon which is a secondary carbon. Okay, right? I know we were joining in secondary carbon in first one and we called it iso, but in here when we join there, we still have a chance. So sec-butyl, secondary butyl, what happens? We are still putting our 4 carbons like this, but now the missing hydrogen is on a secondary carbon, just like that. Okay, so here what we are going to do is we are going to just put hydrogen H, 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 right? And there we go. Right? Now what we are going to do is leave the hydrogen missing at a secondary hydrogen. Then once we have it like that, once we have it like this, and then it's fine. So this is going to be called the secondary butyl. Why? Because it is occupying, because the missing hydrogen is on the second. Okay, that is where the bond will be. The bond is going to come here where there's that missing thing. So that is sec butyl. Okay, so if you were to put it on diagram, you could. I mean, I'm just going to do the I'm just going to do the notation, right? What would I do here? What would I do here? I would just put it like this, down. Okay, we're going, and then what would I do here? I have 1, 2, 3, and then 4. Okay, although 4 are not the right thing. But what would I do here now? All the tips, remember that all the tips, okay, all of the tips are carbons. All the tips are carbons. So what would I do in this situation? In sec butyl, where am I going to place? Where would I place? You have something like this, or maybe let me put it nicely. You have something like that. 1, 2, 3, 4. You have 4, sorry. This is going to be your 4. And you just come to a second carbon and then you put something like that. That's going to be your sec butyl. Okay, sorry for the other one. You on the secondary carbon, just one of the carbons in the center there, that is bonded. Secondary carbon will be a carbon that's bonded to 2 other carbons. Okay, before you look at the continuation, it's bonded to 2 other. Now, number 3. Okay, we've seen N-butyl and we've seen sec-butyl. Now we only want to see isobutyl and tert-butyl. Okay, what is the isobutyl going to be like? Well, isobutyl is going to come from this thing, from the isomer. It's iso because it's coming from the isomer of butane, something that still has 4 things. Okay, it's still going to have 4, but it's going to have 1 like that. Okay, still have 1, 2, 3, 4, but we've turned it like this. Okay, so now what we want to do is, now that we have isobutane, okay, it's an isomer of butane. Now what we are going to do, and remember that the name is actually not isobutane, it's systematic name. The names we are doing right now, both iso, sec, butyl, whatever, they are common names. If we're to give it the proper names, it wouldn't do that. It would say 2 something something, you put the location and then you put the name. So in this case, but we're going to be using this. We are doing tert butyl. Okay, we start by isobutyl. What happens in isobutyl is your attachment will come on the end of this Y, so it will come like this. Okay, right here, and then that's where it would be attached. So I can close off like this to show that here is where attachment has happened, right? So that is going to be your isobutyl. You write it as one word. Now, how do I easily see an isobutyl? Isobutyl kind of makes a Y shape again. Okay, this here, like we saw in isopropyl. But then after that, it makes a slight bend to the to put a link to the continuation, right? To the main chain or to the parent chain. That's our link. This link is coming from your Y. Anything that's iso will have a Y shape. Okay, anything that's iso. So this is your isobutyl. Now number 4, I'm now not really putting the structures. Number 4 is going to be tert det butyl. Okay, so NB. So then now we have the sec butyl. Then after we saw isobutyl, now we are doing tert. Tert is from tertiary. Tertiary means the carbon is bonded to 3, so it's going to be just like this. I have a carbon and it's like this. Okay, this is how we normally do it. This is my carbon. I want to see it's going to be like that, right? So here we have how many carbons in this? I have 1, 2, 3 carbons, right? I have 1, I have 2, I have 3. Then the 4th one is going to be right where they are joining up like that. Okay, right where they're joining up. Now, if I were to extend like that, okay, and I block this and I put an X. Even if I don't put an X, I do this. I'm showing that this is the chain that is going to the main or the parent chain. Now I have these 4. Okay. Now if we look at that carbon number 4, it's a tertiary carbon because it is bonded to carbon 1, 2, 3. It's bonded to 3 carbons. So this is what makes it a tert butyl. Why is it butyl? Because it has 4 carbons in total. As long as you have 4 carbons in total, you're a butyl. Okay. But now because it has 3 bonds elsewhere, then that is going to be the problem. So what is it now when it's like this? Okay, in your tert butyl, you've seen that on the tertiary carbon, that is where it's coming to join. Okay, that is where it's coming to join. But the names, remember that the names will not be if you use IUPAC, but you can use common names. It's acceptable, and you'll be done. So I'm just going to summarize for you at the end. Methyl, we have the first one, methyl, and methyl was just a dash, then CH3. Okay, then we had ethyl, and ethyl was just a dash, then CH2, then CH3, like that. Okay, and then N-propyl, the normal propyl has 2 types. The N-propyl, what did it look like? It was just a normal propyl, and then on the end something just connected like that. So you could do that. Okay, and then what else do you have? So this is the same as saying dash is C3. Okay, it's going to be C3-C3H7. Okay, instead, so that's just how it is. Instead of being H8 like alkanes 2N+2, we look at the general formula. We looked at it. Now the second one is the isopropyl. We write it as one word, isopropyl. What is it going to be? We have our nice propyl here, and on the second part, that is where you're going to have the attachment, and this is how it is. Then what is the next? We'll do N-butyl, right? N-butyl. And what is it that we say? N-butyl is the normal one, so it's just 1 2 3 1 2 3 4 1 2 3 4, like that. And on the fourth one, we are going to just put something else, and that is going to be what we cut. Okay, that is how it is, and that's the connection to wherever, to the parent chain. Okay, sorry for it being very small. Now after N-butyl, then we're going to look at the sec-butyl. Okay, sec-butyl. You put, for sec you put a dash. You say sec, then butyl. Okay. Now what would happen in this case? We have our same thing here, like this: 1 2 3 4, our butane or whatever it is. Then on the second one, that is where we break in, and what is killed is the secondary butyl. Okay, it did 1 2 3 and 4. This is not a bond because it's cut like that, so we don't count the tip. Okay, then the next is going to be the isobutyl. Okay, isobutyl, what do we do? Looks like a T, right? It is something like this. You have something like this. Okay, now what would happen if I say, remember this, I'm trying to make the isobutyl. What would happen in this case is, for your isobutyl, you would have, if you were to count the carbons 1 2 3, right, you'd have 3 carbons, so you'd have to make the fourth one, which makes the Y, right? This is a Y, and after the Y you can just put the bond that connects, okay, and cut it like that. That is it, and that is your isobutyl. It looks like a Y. Okay, it's connected just like that. Iso. Okay, it's like an isomer, right? Remember that. Okay, now the last one is going to be tert-butyl. So what is the tert-butyl going to be? Tert-butyl is going to be, we have everything linked to that one carbon. Okay, it's going to be going to everything, and this is carbon number 3, and then it will have something like that. So this is going to be a carbon. That's 1, that's 2, that's 3, that's 4. Okay, and that's it. So that is tert-butyl there, because it's connected to a tertiary carbon, a carbon here at the center, which is connected to 3 other things, right? All right, so once you have it like this, you are done. So isobutyl and tert-butyl, don't forget them, and don't forget N-butyl and sec-butyl. Okay, N and sec are related to butane. Okay, then these guys are related to the third guy. Okay, and you'll be done, which is the propane. Okay, so never forget it, that sec is just joining on the second. An N is when you just join on the end. Remember, when you count the number of carbons, you count 1 2 3 4, the end, right? Then after the end we put a line joining, but we don't count on this line because it is crossed out like this. And then we do the same for everything else. Okay, secondary, remember what secondary butyl comes from. It's not really like, say, from number 2, but we say it's from a secondary carbon. That's why we say sec-butyl. Okay, and tert is from tertiary carbon, not really carbon number 3. Isobutyl is just that one that makes a Y, and we are done. Okay, goodbye for now. See you in the next video.